Toronto's Line 5 is finally moving. When a transit line opens, the first thing you see isn't technology, it's people. A lineup forming, phones up, voices chanting. And then it happens. The moment the doors close, the story shifts. A train rolls in, doors open, doors close, and in one moment, a project that lived for years as maps and construction becomes a working transit line. This is Line 5, and what Toronto actually built under Eglinton. Line 5 isn't just a new route, it's a new type of transit system for Toronto. So how does Line 5 actually work? Who runs the line? Who owns the trains? And who operates them day to day? How are these vehicles powered, and why overhead power matters? Why does Line 5 feel like two systems in one? For more than 15 years, Eglinton has been in transition. Not just construction, transformation. Intersections were rebuilt, utilities were relocated and modernized. Road layouts were reworked, and the corridor slowly adapted to make room for rapid transit right through the middle of the city. For a long time, Line 5 wasn't something you could ride, and with that, the next question becomes simple. Who's actually behind this system, and who runs it day to day? One of the most confusing parts of Line 5 is who does what. Most people assume the TTC owns it the same way they own the subway. But Line 5 is a shared system. The infrastructure and vehicles are owned by the province through Metrolinx. That includes the stations, tunnels, tracks, and the trains. The system was delivered under contract by Crosslinx Transit Solutions, and major long-term maintenance is handled through that contract. And then there's the part riders interact with every day. The TTC operates the service, TTC staff operate the trains, manage day-to-day service, and run the customer-facing side of the line as part of the TTC network. So on Line 5, ownership, major maintenance, and daily operations don't all sit in one place. And that matters, because when performance is discussed, the responsibilities are split.
It's not working!
So you have to get on the next train, sorry.
Why was there no announcement then?
Now, the part everyone notices first, the trains.
Please stand clear of the doors. Veuillez vous éloigner while the train is in motion. Please remain seated and hold on to the handrails. Pendant que le véhicule est en
The vehicles on Line 5 are not streetcars, and they're not subway trains either. They're Bombardier Flexity Freedom light rail vehicles, designed for rapid transit running in Toronto. The TTC fleet for Line 5 is numbered starting at 6,200. These LRVs were built for a specific job because Line 5 isn't one environment. In some sections, it runs underground with stations that feel subway-like.
Please stand clear of the doors. Veuillez vous éloigner.
In other sections, it runs at the surface, moving through intersections, signals, and city streets. So these vehicles are built to transition between both worlds. Now, here are a few features you can actually see and hear. Line 5 vehicles use a low-floor design for step-free boarding, and the doors use a safety system that can detect an obstruction while closing, reopen, and retry up to 3 times before staying open so an operator can investigate.
Please stand clear of the doors. Veuillez vous éloigner des portes.
And if the train goes into emergency braking, it can continuously sound the horn and flash hazard lights until it's reset. And one more important piece. The Toronto Flexity Freedom fleet is designed to run as train sets. Each car has a cab at one end, so 2 vehicles can be coupled back to back, giving the train a cab at each end. Now, let's compare them to Toronto's Flexity streetcars, because they can look similar at a glance, but they're built around different rules. First, the rails underneath. Toronto streetcars run on Toronto gauge. That's 1,495 millimeters. Line 5 runs on standard gauge, That's 1,435 millimeters. Next, size and performance. Flexity Freedom vehicles are wider, and they're built for higher top speeds than the Flexity Streetcar fleet. Then, doors and direction. Toronto's Flexity Streetcars are unidirectional, with doors on the right side only. But even though they're unidirectional for passenger service, the Flexity Streetcars have rear auxiliary controls, so an operator can still reverse the car when needed for turnbacks or maneuvers. Flexity Freedom vehicles are bidirectional, with doors on both sides, because platforms on rapid transit lines can be placed on either side, depending on station design. And underneath, the track geometry is different too. Streetcars are built to handle much tighter curves and single-point switches in mixed street running. Flexity Freedom vehicles require larger curves, a minimum curve radius of 25 meters, and use conventional double-point switches. Power is also different. Line 5 vehicles use 750 volts DC and collect power by pantograph only. Toronto's Flexity Streetcars run at 600 volts DC and can use a trolley pole or pantograph. And finally, control. These vehicles are equipped with automatic train control, with different operating modes depending on whether the train is in the yard, in the tunnel, an elevated section, or out on the surface. Now that the vehicles are clear, the next question is power. How do these trains actually get electricity? One of the biggest differences between Line 5 and the subway is power. Toronto's subway lines use a third rail. That third rail carries 600 volts of direct current. Line 5 uses overhead power instead. Its overhead system supplies 750 volts DC, so instead of a shoe contacting a rail beside the tracks, Line 5 trains collect power from above. A pantograph on the roof presses up to the overhead wire and draws electricity as the vehicle moves. This isn't just a technical detail. Third rail works well in a fully separated subway environment, but it's extremely dangerous anywhere the track area is accessible. That's why overhead power is a better fit for a line that runs both underground and out on the surface. And overhead power is more than just wires. Along the route, traction power substations take electricity from the grid and convert it into the direct current the trains use. That DC power is then fed into the overhead contact system, so the voltage stays consistent as trains move from station to station. Here's a fun Toronto detail. The subway and the streetcars actually share two old TTC standards. They both use 600 volts DC for traction power, and they both run on the same Toronto gauge track. That gauge is 1,495 millimeters. Line 5 is different. It uses standard gauge, 1,435 millimeters. That's the same gauge used by most railways in North America, including freight railroads and passenger services such as GO Transit, Via Rail, and the Northlander. And it uses a higher voltage overhead system because it was designed as modern light rail from the start. And with surface running comes one more requirement: safety systems that can handle streets, intersections, and everything that comes with them. When rapid transit runs underground, the biggest challenge isn't speed. It's keeping people safely separated from the Guideway. That's why the underground stations on Line 5 use a two-stage Guideway intrusion detection system. Stage 1 is right at the platform edge. Sensors monitor the area above the yellow tactile strip, and if someone crosses into the danger zone, an audible warning alerts them to step back.
An intrusion has been detected in a restricted area. Please return to permitted areas. Your actions are being recorded by CCTV.
Stage 2 monitors activity on the tracks. If something, or someone, is detected where it shouldn't be, the system can automatically trigger a stop for approaching trains. And it isn't limited to platforms. Scanners are also installed at tunnel portal entrances to help detect intrusions near the tunnel areas. So if a train slows down or stops in the underground section, even when nothing looks obvious from far away, it can be the safety system doing exactly what it was designed to do. A lot of people will look at Line 5 and ask, isn't this just a streetcar on Eglinton, or is it basically a subway? The answer is, it's built to be something in between. Underground, it can feel subway-like. Smooth motion, controlled sound, a rapid transit rhythm. Then the line emerges, and the city comes back. Light changes first, then sound, then the visual rhythm of the route. On the surface, it's still not a streetcar experience. Streetcars mix into traffic. Line 5 largely runs on a dedicated right-of-way. Its own corridor, its own stations, its own guideway. That separation is what allows more consistent service. But even with dedicated space, it still lives in the city. Signals, crossings, pedestrians. So the goal isn't perfection in one clip. The goal is steady service through real conditions, day after day. And that's what makes Line 5 important. Toronto didn't just extend the subway, it created a new east-west spine that connects neighborhoods and reshapes travel across the middle of the city. So what is Line 5, really? It's rapid transit, built to operate underground like a subway and above ground like a modern LRT on the same line. On a new transit line, one of the most important features isn't speed, it's access. Line 5 is designed so stations and vehicles can be used by everyone. That starts with level boarding. Instead of climbing steps, riders can roll straight on with wheelchairs, strollers, carts, and mobility devices. And for many riders, the biggest difference is the gap. On Line 5, the goal is a close gap and a level platform, so boarding feels smooth, stable, and predictable. Now let's talk about navigation inside the station. You'll notice tactile strips along the platform edge and across key walking paths. These textured strips are there to be felt underfoot or with a cane. They help guide riders, warn when you're approaching the platform edge, and support safer movement through busy spaces. The simplest way to use them is this. Follow the textured guidance paths toward key points like elevators, stairs, and exits, and treat the yellow tactile edge strip as a clear warning line near the track. Elevators matter. On Line 5, elevators aren't an afterthought. They're built into the main station layout, so riders using mobility devices can move between street level, concourse, and platform. Now, the vehicles themselves are designed with accessibility in mind too. You'll see designated open spaces for wheelchairs and mobility devices, and folding seats nearby that can be flipped up when more space is needed. The layout is meant to make boarding and positioning straightforward, without forcing riders to squeeze into tight corners. But accessibility isn't only about design, it's also about reliability.
Attention folks, the first accessibility door is out of service. Please.
Sometimes a key accessibility feature may not work as it should. So what happens then?
It's not working.
If an elevator is out of service at a station, a wheelchair user may need to change plans in real time.
I go back upstairs. I wait for a 34 bus, which now runs only every 20 minutes.
That can mean riding back to a station where the elevator is working, reaching street level, then using a surface route, like a bus connection, to reach the intended stop. It's a detour that takes more time, but it's the practical reality when one link in the accessible path breaks.
Please stand clear of the doors. Veuillez vous éloigner des portes. While the train is in motion, please remain seated and hold on to the handrails.
Pendant que le véhicule est en mouvement,
If you've ever wondered how Line 5 knows when to go, it depends on where the train is. In the underground portion, Line 5 uses automatic train control. The train's position is confirmed using track markers called norming points, and the control system manages safe spacing and movement through the tunnel section. But once the line comes back to the surface, the operating world changes. At street level, the train is running through real intersections, and that means you'll see the operator actively driving. In the cab, you can see manual control in action. watching signals, approaching stop line, and timing the move through crossings the same way any surface railway has to. So underground can feel smoother and more subway-like, because it's a controlled environment, and surface running can feel more like city transit, because it's governed by intersections, crossings, and street-level operating rules. Same line, same vehicles, 2 different operating modes, depending on where the tracks are. Line 5 has 2 different boarding worlds. Some parts feel like a subway, but on the surface, it becomes something else entirely. These are open platform stops. They're built in the middle of the street, with tracks running down the center median, and platforms designed specifically for LRT boarding. Most of these surface stops use a parallel side platform layout. That means one platform for eastbound service and a separate platform for westbound service, running parallel to each other on either side of the tracks. It's simple, it's familiar, and it keeps passenger flow organized by direction. But there's one above-ground stop that stands out.
Arriving at Sloane Station.
Sloane is built as a center platform stop. One island platform, serving trains in both directions. That changes the whole feel. Everyone gathers on one platform, and the trains arrive on either side. Now, platform layout is only half the story. The other half is where the stop sits relative to the intersection. A lot of LRT stops are designed as far side stops. Far side means the train crosses the intersection first, then stops to load and unload passengers. So in simple terms, for an eastbound train, a far side stop sits on the east side of the cross street. For a westbound train, a far side stop sits on the west side of the cross street. It's a small placement detail, but it changes how the line moves through intersections, how signals interact with trains, and how the stop feels from the rider's point of view. So when you watch Line 5 at street level, you're not just seeing platforms, you're seeing design choices, parallel side platforms versus a center platform, and far side placement to manage intersections, all working together to keep the line moving. If Line 5 has to prove itself anywhere, it's Eglinton Station.
Eglinton Station. Changing for Line 1 via University.
This is already one of the TTC's biggest interchange points. So the real test here isn't just the trains, it's the connections. Because this is where Line 5 meets Line 1, and the station has been modified to make that transfer work. One of the biggest changes is the Line 1 platform. Line 1 trains now stop about 24 meters farther north than they used to. The reason is simple. The Line 5 connection is on the north end of the station, so shifting the stopping point north makes the connection between Line 1 and Line 5 more direct for passengers. Even with that change, the south end of the platform still needs to remain accessible for elevator access and the bus terminal connections, so sections of the platform are partitioned off to block access to the tracks, and those partitions also narrow the passage through that area. At a station this busy, a sign, a corridor, or a barrier can be the difference between a seamless transfer and a stressful one. Eglinton. It's not just a station, it's where the Crosstown has to stitch into the TTC network under real passenger volume. Every transit line has a personality, but the easiest place to understand what a line is for is at the ends. Because end stations aren't just last stops, they're transfer hubs. They're where the line plugs into the rest of the city. And on Line 5, the two ends tell two very different stories. On the west end, Mount Dennis is built as a true connection station. Right away, you see it in the signage. Wayfinding points you toward the bus terminal and toward regional rail. Mount Dennis links Line 5 with a full TTC bus terminal and direct connections to GO Transit's Kitchener line and the UP Express. It's designed so riders can arrive by bus, transfer to rapid transit, or jump onto GO and UP for a completely different kind of trip. And this station has a piece of Toronto history built right into it. Kodak Building 9. It was built in 1939 as part of the Kodak campus. Instead of being demolished, it was preserved, moved out of the way for construction, and then returned to become part of the station. Today, it isn't just a backdrop, it's an entrance. A visible reminder that this line didn't just add transit, it reshaped a whole corridor. And Mount Dennis is also a starting point in another way. This isn't the end of the Crosstown story. Construction is underway on the west extension, which will push the line farther west from Mount Dennis toward Renforth. So when you're standing here, you're not just looking at a terminus, you're looking at the beginning of the next phase. On the east end, Kennedy is all about connections and volume. This is where Line 5 ties into Line 2 subway service and into the Kennedy GO station on the Stouffville line. It's also a major bus terminal with multiple bus platform areas and passenger pickup zones. So the station is constantly moving people between systems. And this is where wayfinding really matters, because Kennedy isn't one platform. It's passageways, elevators, concourse levels, signs telling you which direction to go, depending on whether you're heading to Line 2, GO, or buses. So the end stations show you what Line 5 is trying to do. Thanks for watching. If you enjoyed this video, be sure to subscribe to Urban Digest and turn on the bell so you never miss the next upload. And if you know someone who'd enjoy this video too, share it. Check out our channel for more videos.
Please stand clear of the doors. While the arriving at Arrivés à O'Connor. Please stand clear of the doors.
Veuillez vous éloigner des